Assalamualaikum warahmatullahi wabarakatuh. This is the second part of the video, chapter 16 with motions. Alright, let's go and custom the idea of the speed. Okay, so the speed of wave now on string. So very precise pada tali macam mana. Number one, recall bahawa the given expression over here is not meant for wave. Okay, this is not for wave, but it was for medium particle, mass and medium, right? Whereas VF lambda is for general of wave, gelombang secara general. Tapi when it's very tailored to stretch string maksudnya tali tu mesti tegang. Kalau tali tu tak tegang, gelombang tak wujud. Itu maksud dia. So it was tension over mu. Mu ni linear mass density. Okay, linear mass density. Baik, salin sikit. Linear mass density adalah mass over length. Mass over length. Alright, let's apply this. Example 16.3. The speed of a pulse on a cord. A uniform string has a mass of 0.3 kg, length 6 meter. Now, what's the use of these two data? This will give you the mu. Mu ni mass over length. 0.3 divided by 6. That was the mu. Now, the string itself passes over a pulley. So, lalu dekat hujung tu ada pulley. And a support of 2 kg object. A support here. Now, my picture somehow closing up, overlapping with the given figure. But do check your figure. So, basically, there should be a hanging mass over here. The hanging mass over here is meant to stretch the string. Maknanya tugas yang tergantung tu adalah untuk tegangkan tali. So soalan dia, get the speed of the pulse. Speed of the pulse ni adalah, pulse is wave. Pulse gelombang. Pulse tu gelombang sebenarnya. Denyut tali. Travelling along this string. So what you need to do is, generally, V speed is tension over mu. So tension is mg, 2 darab 9.8. So that's why 2 darab 9.8. Mu is mass over length. Mu is mass over length. So 0.3 divided by 6. And then this susun balik. Then this is how the expression turns into. Solve, you're going to get 19.8 meter per second. So nanti akan ada satu gelombang. Kalau gelombang tu ada atas tali ni, kelajuan dia adalah satu saat 19.8 meter dia bergerak. Kelajuannya far away. Alright, our example 16.4, it still deal with the speed of wave on a string. But the only difference now, the string itself is in a vertical position. So what does it say? It says there is one man, a hiker. How do I know the gender? Okay, a hiker, 80 kilogram. He is strapped on a mountain ledge following a storm. Okay, senang cerita dia terperangkap lah. So a helicopter rescues the hiker by hovering above him and then lowering a cable. So hantarlah satu kabel, likewise here. And then what happened is, the mass of this cable itself is 8 kg and total length from here until here is 15 meter. So here is the helicopter. My hand is now the helicopter. Now a sling of 70 kg is attached to the end of the cable. So over here, there was a sling. Sling tu maksudnya dia nak pegang degai lah. Ataupun mungkin pengusung dia ke, ataupun pengikat badan dia. That itself is 70 kg. I think 70 kg by right is a most probable macam bag tu lah bentuk dia. Then what happened? The hiker attach himself to the sling. Oh, maknanya sekarang hiker tu duduk kat bawah ni. So, what we have at the bottom is not only hiker, tapi termasuk dengan sling yang ada bag tu. Try bayangkan macam tu. So, now, the string itself, kalau tadi kita nampak slacken, right? But because there is a mass at here, which made of, apa mass dia tadi? Hiker plus dengan the sling. Right, which a total of 70 dengan berat man tu apa 80 ya 80. Alright, so and then he said they says that the helicopter accelerates upwards. Pun dari accelerate kan laju, okay, laju. So therefore that hiker become terrified, and terrified by hanging from the cable in the mid-air, the hiker tried to signal the pilot by sending transverse pulse up the cable. Kenapa dia tak jerit? He was in the air. So basically it was very noisy because of the helicopter punya blades rotating. So there's no point of crying yourself out. Memang orang tak dengar. So that's why he send wave. So send wave tu maksudnya sambil macam tu dia ketuk tali tu. Dia ketuk. Macam tu. So he was sending the wave up through the cable. So that pulse, it travel and take 0.25 to travel to the length. Maknanya daripada sini 15 meter tu, daripada bottom here sampai ke sini 15 meter, jarak dia ambil masa 0.25. So ni question, what will be the acceleration of the helicopter? Okay, so what we did is, number one, look at the speed of the wave, tension over mu, and then kita simplify mu kali dengan v squared. And then for the helicopter itself, for it to be travelling, experiencing acceleration, we will find that tension minus mg, ini physics 1, equivalent to positive ma, because helicopter is travelling upwards. So simplify acceleration is tension minus g, tension over mass minus mg. Alright, so what we did is, from the two expression, kita substitute. Masukkan satu-satu. Masukkan ke dalam masing-masing. So kita masukkan tension is mu kali dengan v squared. So now tension disappear, masukkan. And then we have a new one. From here, tak payah sampai sini lah. From here, you go back to the idea that you have learned earlier. And then solve accordingly. Bahawa v tu macam mana. Okay. That v is, here is what makes different adalah sikit kat sini. Sorry, I missed this point. That the v is actually wave. Now, a part of F lambda, a part of tension, maknanya a part tu selain ya. Selain pada rumus ni, selain pada rumus F lambda, the idea that it move at constant speed means that dia tak ada acceleration. Bila tak ada acceleration, v dia acceptable to have x over time. X over time. Okay, x over time. So you nampak v ni nanti kita akan buang, kita akan gantikan dengan x over time. V kuasa 2 and x over time kuasa 2. So satu lagi nota aku nak add on bahawa v tension over mu square roots, v is f lambda, and then v also delta x over delta t. Alright. Mu itself tak ada masalah ya, mass over length ya. Mass over length, cuma kita akan confuse. Banyaknya mass. What mass? Mass dia mesti mass cable. Mesti mass cable. So looking at the situation, mass cable adalah, cable tu tali lah, string tu sendiri 8. Length dia 15. So mass cable over length. Ini mu, product of mu. And then just solve it accordingly. You should get 3. Okay, give it a try. Alright, so the earlier example is wave on a string. Now we have another example of wave, which is sound. So sound is categorized as gelombang juga. Okay. In the next topic, we're going to see that light is also gelombang. So that's why the topic will go in that direction as well. So basically, sounds can be categorized according to the frequency, which are audible. Audible means kita boleh dengar. Audible. Sebut audible. Right? Infra, ultra. So the difference is audible that we can hear is actually just between 20 to 20k. 20k, 20,000. Tapi kalau below 20, paling kecil, infra. Besar sangat, lebih daripada 20k, itu dah ultra. So those ultra usually animals lah. Dolphins, dog, okay. So that's why light yang kita panggil ultrasounds tu, it operating at the frequency bigger than 20k. Alright. So you find that as well here, it says here, silent whistle to retrieve your dogs. This is actually make use of ultrasonic sound. Human cannot hear it. That was very, Malay is very, if you remember, badak sumbu. Badak sumbu is ada satu terms associated ataupun what should I say pekak badak. Pekak badak comes because of when we try to talk to badak, badak would not respond. Tapi badak is considered actually very dangerous animal. Sebenarnya dia bukannya sesuatu animal yang very gentle in nature. Okay, anyway, pekak badak. The very reason is because of what we mentioned just now lah. Kita cakap dia macam buat de aja. The reason that it buat de is because dia punya operating system dia tidak sama macam kita. Dia bukan audible. The language ataupun the ear itself, it's operating dekat infra. Okay. Infra. So, dia punya kebolehan mendengar tu adalah banyak pada bercakap dia pun, bercakap tidaklah. Kita can hear the sound of the roaring. But eventually the operating is infra. So, those old Malays ataupun kita punya otak-otak orang-orang lama kita ni boleh observe that situation actually, ya. Right. Okay, anyway, when the sounds, okay, so this is an example how the sounds progress ataupun bergerak dalam keadaan udara, dia pengkajian pada udara tu sendiri. So, because the eye cannot perceive. Jadi, the study of sound wave ni, dia look at what we call pressure. So, this is the first case whereby the air is not disturbed. Now, what happened is the air now is being compressed. When it compressed, you will notice that akan ada variations of pressure inside the tubes. Variation of pressure ni nanti kita akan nampak bawah kat sini, nampak ni. Dia darker sedikit, then less dark. So that is try to indicate concept of pressure dia berubah. Right. So after this kita akan tengok jenis-jenis pressure dia. So dia kata compressed region, bila dia compress, so compress, you will find that compress means the udara is now packed together. So idea dia itu compress lah. Okay. Kalau udara tu low pressure means that banyak ruang. Banyak ruang becomes large. Pressure means associated with, macam in our class, we have originally 20. And then kita bawa keluar 10 orang, our class now is only 10. So awak pun tak nak duduk dekat-dekat, you're gonna sit sparsely, duduk jauh-jauh. That is considered as low pressure. Rarefaction nama dia, ya. So compression, high pressure, low pressure, rarefaction, rare. Alright, speed of wave as general is also obeying F lambda, but specific for sound in gas adalah beta over Buck modulus, rasa namanya ni, Buck modulus over density. Alright, this is also given in the equation sheet if not mistaken. So double check. Now the speed of sound, but we have two things to consider when we are talking about speed of sound. And additional to that is the speed of sound also depends on the temperature of the medium, because speed of sound really depends on the air particle to vibrates, back and forth, and when it travel, it will pass its kinetic energy to the neighbor, and in short, sound need medium, iaitu air particle sendiri. Jadi that's why there's no sound in the outer space. Itu idea dia. Jadi eventually, the movement of the air particle is also dependent not only of the energy coming from the sound or disturbance. Okay. It's also dependence on the heat temperature ketika tu. Panas tak? Kalau panas means dia lagi laju dia bergerak. Macam tu, for example. So that's why the expression is as such. Okay, so this expression substitute C here to indicate bahawa temperature yang you akan masukkan adalah dalam bentuk Celsius. Okay. Okay, pegang these two expression. Kita akan tengok examples now. Alright, before we look at the example, there was this additional notes as well. 16.8, intensity of the sound wave. So, this is a technique to measure. We have two technique actually, intensity and intensity level. Ada beza intensity level. Ataupun in the book here, it says here sound level. Perkataan level ni maksud dia lain. Okay. So, intensity adalah power divided by area. Power video area. Sekejap ya, nanti kita akan define area ni macam mana. Intensity level ataupun sound level, it was measured in terms of decibel. The different, dua-dua ni benda yang sama, tetapi kalau kita go by this version as a human, kita akan nampak the number is random. Kita tak nampak dalam satu version yang give meaning to us. Agak-agak susah nak faham numbers dia. Jadi what we did is kita proceed dengan satu teknik, we call it as intensity level. Intensity level is a process where intensity of the sound itu, kemudian kita buat comparison dengan intensity sound, threshold of hearing. Okay, threshold of hearing. I yang ini adalah nilai dia 1 times 10 to the -12. Yang ini memang pakai. Okay, pakai dan guna. Ini biasanya kita minta hafal Okay, threshold of hearing kita panggil. Dalam bentuk intensity, tengok watts per meter squared. Watts per meter squared sebab power per meter area. Alright. And then logkan the product of this ratio and then times 10. So basically, bila kita times 10, kalau kita dapat jawapan dia 10, ni dah ada reference dah. 10 is hampir sama dengan bunyi daun yang bergeseran. Rustling of leaves. Kalau you berbisik, whispering 30 decibel. dB ni decibel. Okay. Normal conversation would be 60. Kalau you jenis suka cakap kuat-kuat sikit, 65 kot. Right. Vacuum cleaner is really disturbing, dah tinggi dah ni, 70. Traffic jam, ASF 80. Okay. Dekat subway, 100. Rock concert, 120. Rock concert ni dah consider dah kawasan yang bahaya. Because 120 is actually dah sampai threshold yang berbahaya kepada ear awak. Now the sound, kalau kita relates with the ear, the shape of the ear adalah ada anvil, betul? Ada anvil, ada drum. So you hear sound, the sound goes into your ear. Ear tu kita ada bentuk capang telinga tu is to capture as many air particle as possible. Jadi orang selalu cakap, untuk tu selalu cakap, kalau telinga tu besar sikit, you can hear louder. Yes, you can hear better. Betul lah tu. Sebab the ear tu akan capture more air particle. And then dia akan ada channel. The canal, kalau kita belajar biology, kita akan pakai canal. The ear canal tu meant untuk salurkan very focus. Okay, very focus the sound. Bila at the end of the tunnel, at the end of the canal tu, nanti baru kita jumpa anvil and the drum. Jadi nanti kita akan translatekan energy daripada air particle yang bergetar-getar inside the ear, and then pergi dekat anvil. Anvil tu akan kuatkan bunyi tu dengan do the drumming. And then drumming tu akan drum on the surface of the tympanum tympanum. And then dia akan transfer dalam bentuk physical sentuhan, bentuk motion, and then vibration from the soft tissue tu akan transfer pula, converted into electrical signal untuk translation pula. That's how the idea of sound dia diperhatikan lah. But eventually rock concerts ni, when it gets too large, means that anvil tu akan buat sangat laju untuk pukul the tympanum. So eventually prolonged exposure ni akan menyebabkan dia punya elasticity of the tympanum tu will be lost. Loosen lah dia, jadi dia tak tegang dah. It's no longer in a stretch portion. So when it's not in the stretch portion, dia dah tak efektif sangat untuk pendengaran. Tu sebabnya rock concert akan senang menyebabkan telinga rosak. One. And that's include kalau if you plug earphone directly over here. And again, that's why kita ada invention conduction earphone. Conduction yang kita letak dekat tulang kepala. Sebab kalau kita go with the idea of how you hear, not only you hear through your ear, but the whole portions of the parts of the crane, sacral, what is it tulang kepala awak tu, susah nak recall terms dia, that is as well one way of hearing as well, sebab dia punya bone tu akan bergetar and as well translate pergi balik dalam telinga. So that's how complex of hearing is. So that's why kalau satu tak berfunction, insyaAllah still lagi okay capacity of hearing awak, because we are supported also by the skull of the brain, of the head, sorry, not the brain, okay, skull of the head. Okay, let's now have a look at this example 16.7. So from this example, it's given that there is 1 point source, satu source point, and then it emitted sounds that average power output dia adalah 80 watts, and then dia kata get the intensity level if the distance is 3 meter from the source. So look how it was measured in terms of the area. Area dia adalah 4 pi r squared. Okay, 4 pi r squared. It was measured dalam bentuk seperti bulatan, and then bulatan tu punya luas dia berapa? Luas dia berapa? 4 pi r squared. Okay. And then accordingly, this is the answer. Cuma yang ni kena hafal lah. 4 pi r squared is the area. Right, second question, find the distance when now the intensity itself is 1 to the power of negative 8. Tadi dia suruh cari, yang ini kita dia beri pula. Jadi with this as the intensity, masuk balik dalam rumus ni, masuk kat sini. And then power masukkan 80 balik. And then 4 pi are unknowns. So ini susun, you're gonna get RS 2.52. Maknanya pergi rumus ni. Tak payah susun pun tak apa macam dia. Alright, increasing the intensity of a sound by a factor of 100 causes the sound level to increase by what amount? So this question, they would like you to get what will be new dB and then compare with the previous decibel. So eventually, the original expression is dB is equivalent to 10 log I over I naught. Okay. So when we say increase by what amounts, we can say that we can have it in a form of differences, minus with one another. The new one, we tend to write it as this one. Untuk dia macam ni. New minus the original. And then this expression, 10 log I per I naught minus, again the same expression, 10 log I over I naught. The only thing that we make a comparison, because now increased by 100, it's going to be this. Okay. So mathematically, when we have this log minus together, kita boleh buat factorization. Factorization dia akan berbunyi begini. 10 log, salin balik. Whatever the number here, akan bahagi dengan number ni. Jadi dia akan bunyi 100 I over, I over dengan I naught, and then divide balik dengan I over I naught. Jadi expression ni akan tinggal only equivalent to 10 log 100. 10 log 100, tekan calculator, you're going to get the answer. Okay. Alright, let's have a look. Example 18.4. Sorry, 16.8, sound level. Perkataan level indicating it's now using log. So, two identical means same power. Machine yang sama are positioned at the same distance from a worker. Mana this worker standing somewhere in between them pun bolehlah bayangkan tengah-tengah dia. Dua mesin tengah-tengah dia. So, intensity of sound delivered by each one adalah 2 times 10 to the power of negative 7. Right, so sekarang dia kata kalau only one, find the sound level heard by the worker when only one aja operates. Jadi kita akan nampak power dia singular saja. 2 darab 10 pasal itu 7. And then divide by intensity of hearing. Threshold of hearing, sorry, not intensity. So simplify, you're going to get 53 decibel. Okay, so now the next question, they ask you the same thing, sound level again, but now both machines are operating. So the only difference is, now tadi 4 jadi, 2 jadi 4. So notice that the answer now becomes 56. Okay, the system when you are operating in form of decibel, lain sikit So you tak boleh terus troubleshoot says that when you are operating at twice, decibel level dia akan increase twice. Tidak, tak boleh. Dia kalau 2 sebenarnya dia akan naik 3 saja, 3 decibel. I can change it into different question. I tukar ni jadi 10 kali 10 negative 7, and then kat sini jadi 2 kali ganda, maknanya 20 kan. As I repeat, nanti answer saya akan berbeza sebanyak 3 decibel je. Janganlah hafal, buat je lah. Okay. So eventually keep bottom line dia when you are dealing with decibel, you jangan main doublekan dia sahaja untuk jawapan akhir ni. Bukan 53 dah harap dengan 2, 106 tu salah. Okay. You kena pergi balik proses basic of getting log dia. Alright, let's have a look at Doppler. What is Doppler? Doppler is a situation where the frequency is different from the original frequency because of the object or you is now in motion. Maknanya kalau you bergerak, bunyi tu akan lain. Kalau dia bergerak pun bunyi tu akan lain lah. Right. Let's see ada kita boleh pergi tak? Tak boleh pergi Now, since I cannot click on the given link, nanti on your own, please click it. So you will find that you are gonna hear the product of the frequency differences nanti Bunyi dia, kalau is an ambulance, bunyi dia ni no ni no ni no ni no. Bila dia dekat ni no ni no ni no. Something like that lah. Okay. So eventually there is a difference. Saya bagi awak in the given YouTube, satu lagi adalah dekat track rally So dekat track rally nanti you akan dengar differences dia. And then bila you duduk dalam kereta tu sendiri, you don't hear any differences. Okay. So basically, this expression is given. Expression ni maksud dia apa? F on the right side ni adalah F original of the source. F original source. Katalah saya menjerit. So saya original source lah. And then you duduk sana, duduk depan saya mendengar. Okay. So ni adalah frekuensi that you will hear. Faham? So usually yang ini kita sebut, you boleh adjust balik rumus awak. Ni observer to the left ni. Yang sebelah kanan ni adalah source. Okay. So the way that we implement kita punya equation, dia bagi contoh kat sini kan. V kat atas ni dihilang. O ni observer S ni source. So situation yang sebelah kiri ni adalah di modified rumus when observer tidak bergerak tetapi source bergerak. So disebut source moving towards stationary observer So you will find that since perkataan towards, jadi kita akan employ plus. And then plus ni kita akan letakkan simbol plus ni bersebelahan dengan V source. So original rumus V source adalah V tolak tambah VS. Jadi sama dengan tolak jugalah. And then in a case that kita custom situation, source moving, observer masih lagi stationary. Okay, jadi ni hilang lah. Tinggal V saja. And then since terms dia moving away, perkataan away ni akan beri awak kena letakkan simbol negatif ni. So you place the negative next to V source. Okay, jadi dia jadi tolak V tolak V source. Jadi itu yang V plus V source. Alright. So that's number 2 lah. Towards away. Towards positive, away negative. You tengoklah situasi. That's include kalau case yang kat atas pun macam tu juga. Okay. Perkataan towards and away very important. Right. Next adalah what is this V? Yang V single ni apa? Tadi kita define V source and then frequency source kat sini, frequency observer kat sini kan. Right. V ni adalah speed of sound. Speed of sound. Salin. Right, now let's have a look. Example 16.10 where Doppler is being used. Given question is a submarine A travels through water at a speed of 8 meter per second. It's emitting a sonar wave of a frequency 1400. So this is frequency of the source. Frequency of the source means it's here, resembling this expression is similar to 1400. Now the speed of the sound in the water is 1533. So this 1533 speed of sound in air, speed of sound in water. Since the material, the sound travel in the water, so the V over here without any subscripts is 1533. So if the question is occurring in the air, then it should be making use of speed of sound in the air. Alright, V is speed of sound. Alright, a second submarine, there was another one labeled as B, located at a distance that both submarines are traveling directly towards one another. So in such a way, it's such this, right? So the second submarine now is moving at a speed of 9 meters per second. So the question, what will be frequency detected by observers? So F observer. F observer here is this one, the one with the apostrophe. So for a rider on submarine B, as they are approaching one another. So let's assume my left hand here is submarine B and it should be this is the observer. And this is the source. The right hand is the source, which emitting a sonar wave of a frequency 1400. So by right, when we are moving this way, both is towards one another. I am moving towards B. B is moving towards A. So in such manner, these expressions towards, okay, this is generic expression. So they would bear positive, positive individually on each V itself. Okay, regardless that they both move, one of them, sub B is now moving to the right and this one is moving to the left. Regardless, it doesn't depend on that. Okay, so kita betul-betul tengok pada components towards ke away. So with that, substituting and you get the answer. Right, second question. The subs barely miss one another, means that it doesn't crash into one another. Instead, they just bypass one another and passing one another. So what frequency detected by an observer again on the same sub as the sub receding from each other? Receding means passing away lah, moving away. So it's macam tu. So in this manner, you will have noticed that both is travelling away from one another. When that is being considered from the general expressions, individual V observer of submarine B is now kita substitute negative for both case. Ada negative ni apa? Negative 8, negative 9. Because it's moving away. Recede ni adalah pergi. So now observe that the original frequency is 1400. When moving towards one another increase. When moving from one another is now reduced. Okay. Now, while the subs are approaching each other. So we are coming back to the original situations earlier. So some of the sound from sub A is reflected from sub B and then returned back to sub A. So now what happened is sub A would turns out to be the observer. So original idea dia adalah sub A keluar bunyi. Okay, keluar bunyi. So sub A keluar bunyi. Where's mine? Okay. Sub A keluar bunyi. Tapi bunyi tu gets reflected by the B and then B send it back. I am sending you back the sound. So now you are the observer. So how do we deal with this case? Right. So observe how we consider first the direction. Since they both move in towards the one another, so of course they are positive. However, the observer is no longer sub B. It was the A. So that's why 8 meter per second is considered as observer. Sub A dah jadi observer. Sub B jadi source. And secondly, the source that we are talking about adalah source that comes from yang mula-mula B dengar. From the first case here, when A throws ataupun emitting sound, B receive at a frequency of 1416. And then 1416 being reflected back to A. So 1416 is becoming the source. And then solve it. You get this as the answer. Right. Let's have a look. Example 16.9, a broken clock radio. This is not meant for nursing. Now, the whole idea of this example is whereby there will be an object thrown downwards, undergoes free fall. So, at the same time, it's emitting sound. So, you are on the top of a building and you would like to hear, the question would be asking you, what will you hear sound from that object that's falling down? So the question says the situation is your clock radio awakens you with a steady and irritating sound of frequency 600 Hz. One morning it malfunctions and cannot be turned off. In frustration, you drop the clock from rest out of your 4th story dorm window. Means that you take it out of your 15-meter height dorm from the ground. So you are 15 meter and then you release it from rest. So assuming that the speed of sound is 343, so this 343 is this one. Okay, so observe the difference between the Doppler in the case of the submarine earlier. It was speed of sound in the water, while here it's occurring in the air. So that's why we consider speed of sound in the air. So as you listen to the falling clock radio, where you would be stationary, what frequency do you hear just before it strikes the ground? So basically, we expect that to find the frequency that you will hear is by using this expression. Since you are not moving, observer would be 0. So here is the expression 0 too. Okay. So the one which is moving is the clock itself because it undergoes free fall. Right. So what you need to figure out is what is the speed of this clock itself. Yang ni yang kena identify. So accordingly, looking at the situation of free fall, combining with equation V U plus AT and also delta Y UT half AT squared, consider that delta Y nanti ada negative, right? And substituting into one another. So you will arrive with V final before it hits the ground. Okay, so you can do calculation a little bit on how to get the answer on the answer itself. Once you get the answer, my concern is look at the generic expression V minus V source. You should notice that your substitution should be considering the V itself ada negative with negative product. Why? Because dia sedang moving away, right? Moving away. That's all it takes, okay? So give it a try. So free fall, get first the V final before it hits the ground, 15-meter height, and then from there substituting into the Doppler expression. That's all guys. Thank you.